I just wanted to make a short video kind of wrapping all of that up, sort of a strategy or a summary of what we have to do for partial fractions. So first of all, to do the partial fractions method, you must start with a rational function that is a proper fraction, meaning that the polynomial on the top has a smaller order than the polynomial on the bottom. If it's not the case, for example, if you had like a cubic on the top and just a quadratic on the bottom or whatever, as long as the top is not even of the, it could be of the same, like it could be a quadratic, whatever. If it's the same, even, that's still not good. It has to be one less, okay? So it has to be a proper fraction. And if it's not, divide first. I'll do a quick example in the last video, but just so that you know, if you need a revision or refresher on long division of polynomials, I'll also put some information about that in the extra materials. Okay, so fine with that. Now once you've got your proper fraction, you are going to make sure that your bottom is factored. So then factor bottom. And then you're going to look at what you've got as far as your factors are in the denominator. So your first case is simple linear factors. Right? So what that's going to look like, some polynomial in the top, and whatever, x minus a, x minus b, say x minus little c, whatever. However many you have. You're just going to break that with some constants in the top. There is a trick for these, by the way, that you might have seen or heard of. I can't remember what it is. It's like you cover this up and you do something with that. I don't know what it is. But that trick only works for simple linear factors. That's why I don't ever remember it, because I don't use it, because it doesn't work we have 4 cases here, and so now this trick only works for one case. It's not something I'm going to remember, right? Quite honestly. There are people who do use it because they do things with simple factors a lot, I guess. Okay. So second case, repeated linear factors. So it would be something like x minus a squared, and then of course you have to have something else there to mess around with it. So you have to remember that when you have something to the n, you have to go all the way down, right? From that n all the way to 1. Our third case was irreducible quadratics. So this was the case where I have x squared plus a. Okay? And often this is something nice, a squared, right? But it's not always. You could have something else. But there's always going to be plus, right? Because if it was minus, you could factor it. If it's a plus, you can't factor it. So put something else here, right? So for the x squared in the bottom, remember you have to have something like ax plus b if I've got x squared plus a there. And the linear factor just gets a constant. Now I'm out of space, but I'll try to shove it in the bottom. Repeated irreducible quadratic factors. Would be just like this, only say I had a square there. So, bad board here. I see I should have like started a little bit, I don't know, higher or something. So x squared plus a squared, and this is a, it's hard for me to, times x minus b. So then you have to do, as I did in the example that I did, x squared plus a, whole thing squared, and then one down, just x squared plus a, and both of these get an ax plus b form. But we don't want to write ax plus b twice because we don't want to use the same letter. So some people write a1, b1, whatever, a2, b2. Some people just write a, b, c, d, e, f, g, h, whatever. X minus b. And a couple of things. Of course, it doesn't really matter what order you do these in, right? It doesn't matter if I put in x minus a over there or x minus b, but you have to keep straight which coefficient goes to which, right? So that's why I always tried to make sure when I wrote these problems, I wrote it up so that I know when I'm substituting back into a, b, and c, that I'm substituting into the right thing. Okay, that's another source of error where you substitute the wrong thing into the wrong thing, get the wrong answer, you did all the math right, you just put the wrong number in. So there it is. That's your strategy for partial fractions.